Hello, everyone, and welcome to Building Your First TypeScript Project. We are also joined here, live audience, but we have hopefully many people on the stream joining us around the world. So whenever I'm talking about people on the stream, I'm talking to this camera here, and it's not awkward, but hopefully around the world. So if you are joining us on the stream, let us know one where you're joining from, because that's always fun, and also your JavaScript experience. Maybe you just started out, maybe you're a JavaScript pro, and somehow you skipped like the TypeScript step and you want to learn that. It's always interesting to find that. And our lovely Erica here will shout out random countries and where you're from on the chat. She'll be watching the chat for a bit. But this is a part of a series called TypeScript for Beginners. This is the second part. So if you missed the first part, it's okay. It's more some of the basics of TypeScript and getting your project set up. And I'll talk a little bit more about that later on. But if you were there for the first time, I had many children in the background screaming. And you might be wondering why now I don't have any kids screaming in the background. That's because I'm here in the reactor, and we're also joined by Lucas Santos, software engineer at Klarna. LinkedIn says you like to talk about TypeScript. So that's why you're here.
A lot.
Algorithm says yes. But we're going to go right into it. We're going to do a couple of things. We're going to show you actually how to build a project. So I'm going to talk to you about some of the setup of the project, what the resources we're going to use. I am going to cover some of the TypeScript basics, just the code that Lucas is going to show you a little bit more. Like, I'm not going to steal his thunder or anything, but I'm going to just kind of, if TypeScript, you're seeing this code for the first time, it may be confusing for you. And then we're actually going to build something. I think something cool.
Something very nice.
Yes, hopefully. So for this is for the people in the audience to say yes. Hopefully they're saying yes in the chat as well. But are you ready to build something with TypeScript? Yes.
Yeah.
You can't. Yes. Thank you. Thank you. The people on the stream can't see everyone shaking their head and screaming and really excited in the audience. So we are going to do a project, and I'm going to start off with a story of this project. This little photo here, and hopefully it's showing well in the stream, and hopefully you can kind of see it. I'm not a photographer. I'm a cloud advocate here at Microsoft, so I'm not the best. But in the corner of that screen, you can actually see a little train track, and this is my daily walk to my public commute to the train here in Stockholm. And this walk, I can actually see when the train is coming. But if I saw the train coming at this very moment, I think I'm pretty fast, but not fast enough to catch it. So it breaks my heart every time I can see the train coming and know, but I'm gonna miss the train. Like, I can see it. I'm like, oh, I can't run. Like, even if I try, sometimes it just never works out. And this happens 3 times out of a week. Like, and it's terrible. And my problem is, no one really likes to wait. And I've already alluded to that I have kids. And if I miss the train, then it's normally like a 10-minute wait. And a 10-minute wait on a subway platform is like, I don't know. I don't want to say HE double hockey sticks, but it's terrible for having kids and having them wait for 10 minutes on things. No one really likes to wait. I don't want to miss the train. So I need a good way to actually find in real time when the next train is coming. And I know there's apps out there that Google Maps, I can check it every time, and that's kind of really annoying because then I have to put in where I'm going, and then I look, and they don't really show in real time exactly where my train is coming. And also SL, which is the public transit of Stockholm, they also have an app, but you also have to put in where you want to go first, and then it shows you the time. So I would love a way for me to find exactly in real time the next train, whether it's 4 minutes, 3 minutes, so I can leave my house at the right time. And just to get the stream going as well, let us know if you are what your public transit is called. I'm always curious. I used to live in New York, so it was MTA. Now it's SL. And let us know the color of the card, because blue cards are the best for it. But what we're gonna do is actually work with TypeScript. And again, the first session that we did a lot of actual project setup of like how to install TypeScript. So if you need any help with that, you can go to this link, Getting Started with TypeScript 1, and it's a Microsoft Learn, which is like a Microsoft free online course, basically, and it gives you the steps about installing TypeScript and all of that with NPM. But I don't think Lucas is going to do that, but maybe he will walk you through that as well. And just to talk about it. Last time we did have the beginner session, getting started with TypeScript. We had a nice debate about why we'd want to use TypeScript. So hopefully you're joining us now here on live and in person because you think there is some value or important on learning TypeScript. But we'll probably also talk about a little bit more some of the benefits there. But if you want to join that debate, feel free to add the comments on the last session as well. So, how we're actually going to find the real-time information. So we're going to actually use this API called Traffic Lab, which is Traffic Lab in English. So not only are you learning TypeScript, but you're going to learn some Swedish today as well, for the people who are not in Stockholm. And they actually have two free available APIs. One is the real-time information SL, again, the train tracks, and then a location lookup. So every location in Stockholm, like a stop, even a bus stop, has a number attached to it. And that's going to be the way that we are going to build this project to find out find out exactly what stop that we're interested in and find that information. And it's tricky. I mean, Lucas and I both I think are skilled developers, but it's very tricky to find actually how to get an API key on this site. So the best way to do it is you go to the developer.trafficlab.se project with a K. That's Swedish, and then just find it and just go create new project. That's going to directly then you can choose the two APIs I mentioned, which is the real-time information and the location lookup for that. So, are you sure you want to build a TypeScript project? I hope so. So this thing, like I said, I'm going to cover two basic concepts that Lucas will also show in his code. The first one is interfaces, and interfaces. If we look at some of the code, I think the best way to understand some of the reasons why we write TypeScript is to know what we're coming from or what problem it's trying to solve by using TypeScript. So this is like not interfaces if we don't want to use interfaces and we just want to use our vanilla JavaScript. Let's say we're making two objects like viewers, and we have a viewer name. So this is me. We're going to collect their Twitter handle. So this is me shamelessly publicly putting my Twitter handle here at Korey Space. And then we're going to do like a view count. So how many times have they joined one of our streams or one of our sessions? So we have viewer 1, viewer, whatnot. And then we'll make viewer 2. So this is Lucas coming now. And we have viewer, his name, his Twitter handle again. And we know that we kind of expect this to be a view count as well, but we haven't assigned that. We haven't actually put that in our code. But maybe later on in our project, we're going to say, oh yeah, we need to find out the view count for viewer 2. And right now everything will be kind of working. We will probably get nothing here. But that's where I think interfaces really comes and shines and helps us out here, because if we use an actual interface for this, which is again the syntax here, we can actually do an interface called a viewer, and it makes this kind of thing a lot reusable, and the properties that we place in here, like viewer name, Twitter handle, make sure that we actually use them every time we want to create a new user. So it saves a lot of time and headache when we are making these objects or making these things later on, and then we forget how we actually have made them. So here I've made viewer name, and it's expected the type to be string. Again, if you've never seen something like this, is kind of how TypeScript variables are written. But what's also cool about interfaces is that we can also make them functions, put functions in them. So we can have get likes, for example, and get how many likes or how many times they've liked the video. So then we can assign a new viewer. So let's say this is a recent viewer. It's going to be able to type or using the interface viewer. And then we're going to go ahead and assign all these things. And what's really nice is then I can go in and see here even built into the IDE exactly what we need to define with every viewer, which saves a lot of time. And then I'm going to talk about this later on, but we also have types, and what we can do even with with difference between a type and the interfaces, we can actually what we call open these interfaces up. So let's say later on we wanted to add something else. Let's say like if they're a super fan, for example, we can go ahead and do that by just kind of invoking or writing the interface again, writing that out, and now we will have a Boolean, which is it a super fan. And then what's also nice, we can extend interfaces. So let's say we have a lot of bots that watch our streams. Please in the stream let us know if you're not a bot. That would be great. We can say interface bot viewer. We can extend that interface, and then also put it now as if it's a Boolean, if they're a bot or not. So again, it's all about reusability, especially when writing TypeScript, and especially when working with objects and different properties. It can get confusing a lot or get lost in these types of properties that you're using, and interfaces allows us to do that pretty easier, much easier. And again, if we were to remove some of these things and remove some of these properties, it would flag these errors and give us good guidance on what to do next. So if you that was a really brief introduction into interfaces. If you want to learn more about them, again, we have a Microsoft Learn platform just on interfaces. So again, showing how kind of important it is. And that's going to be at this URL here, building your first TypeScript project one. And for everyone on the stream and in the audience, we have one link I'll share later on that has all of these links there. So don't stress about that. I see some people doing the QR codes, which I love, but yeah, no stress. And then we also have type aliases. Lucas will show in his code a little bit about them, but again, you can basically define your own types within TypeScript, and they look very similar to interfaces as well. And I don't know, we can debate this later on. Some people say that you can use them interchangeably. I mean, they basically function the same way, but the only difference, as I mentioned, is in fact that with the type you can't open it up or add any more new properties later on. So again, that it's a nice way to do such a things like that. Um, so again, almost the syntax looks very similar. I can make a type viewer now exactly the name, email, view count if they're subscribed to the channel or whatnot, and then invoke or even pass in a new viewer for a function. And what's also really cool here is with the type aliases, I can also make them unions, and this is kind of uh, this little square or these straight lines here are unions. So basically like options. Like we only want these certain options attached to this variable. So let's say we have a viewer review and we're all positive here. So we don't want to have no negativity on the reviews. So we can have, let's say, amazing, great, good. And then if we want to come in and say, oh, we have this angry review, and then that viewer review is terrible, we're actually going to get flagged that this is not an assignable type because we've only used the unions here for these sorts of types. So again, it adds some restriction to code and how you write them, but the restriction is a good way to save a lot of time later on, and especially for specific use cases where you need to have these limitations in your code. Where I think if you're writing vanilla JavaScript, it's I wouldn't say Wild West, but it's a little bit more flexibility that can cost you a lot of headache later on when you're writing this out. So, and there's another one session again that's going to be just around type functions and also the type aliases as well. So that's enough talking about some of the uh, basics of things like that in the setup there. But so I hope you're still with us and hope you really now want to write a TypeScript project. Again, like I said, all the links are going to be here, and I'm going to share them in the chat after this. But there'll be all the resources, not only to the repo that Lucas is going to show you later on, but all the Microsoft Learn platforms, and then the recording of this video. So again, you can sit back, relax, and then watch again if you need to. Lastly, this is again a part of a series. So we're actually going to be working specifically on the back end of this application now. But later on, and on the February 15th, so 2 weeks time, we're actually going to build the React front end. What's nice TypeScript is it's basically very similar when you're using any sort of library, but there is some like TSX syntax and things like that that are unique to writing TypeScript. So we're going to build the front end to this application on the 15th. So the story continues. But without further ado,
Yeah,
Lucas, let's actually get started building on that.
nice. Let's do some code. So let me get everything here set up first. And yes, about the interfaces and types, you can use them interchangeably, but interfaces are more performant. I will try to show this in a way, but well, let's not hush things up, right? Let's keep the mystery so we can do some stuff. So I hope.
Erica didn't
Yes, I
do
hope you're seeing this.
the shout outs, but we have some from Greece, Brazil, so your native
Nice.
motherland, San Diego, nice. That's pretty early. And Northern Virginia, JavaScript newbie. Welcome,
Nice.
everyone.
Very, very cool. So let me introduce myself first. Some of you already know me. I've seen some familiar faces here. But my name is Lucas. I work at Klarna. Here I'm a senior engineer. I'm not Swedish. I am Brazilian, so as you can see, everything is written in Portuguese because yes, I forgot to change. But you can look me up on every social network or anything if you want to hit me up on any questions or anything. My website is lsantos.dev. So if you want to go there, you're gonna hit this page, right? Or you can go to my Twitter on @_static_void from Java. Yeah. And yeah, you can just talk to that. So the first thing, like Corey said, we're going to create a simple API. So it's going to be just a single route API that's going to return our station real-time data. So we can consume on the React frontend later on. So it's going to be a very, very simple project. I just created like a folder here with the VS Code here, just I'd like to show you. And then we can start the project here. So first things first, I'm going to open a terminal. This is, if you ask, I got this on my spot. This is warp, the name of the terminal. And I'm just going to do an npm init, and just going to say yes to everything. You can actually do npm init.w. It's just going to say yes to everything. So as you can see, this is going to create a package JSON file here in my project. And well, the thing that I'm going to do is that I'm going to just change the scripts here a bit because we need to build this, right? So TypeScript is a compiled language. We need actually transpiled language. So we need to transpile from TypeScript to JavaScript because TypeScript is just a typeset. So it's a superset of the JavaScript language, right? So what we're going to do is that I'm going to create a new script here called actually dev. We can do like this, dev, or starts better. And I'm going to run npm run build and node dist index.js. This is going to be where our file is going to be, right? So we're going to create a TypeScript file here in a source folder. And this file is going to be like dist, oh, sorry, source.index.ts. I created a folder, obviously. I didn't create a file. So index.ts, right? So when we compile this, we are going to tell TypeScript that this file should be in this folder with the extension JS, right? So we're just going to run this file over there. We're going to change this here on main as well. So we know everything. And we are creating the build script, right? So I don't need the test script because this is not needed. I'm going to do the build, and the build is just going to run tsc. Tsc is the TypeScript compiler. So this is going to be a command that we're going to gain when we install TypeScript in our project. So what we're going to do is that we're going to do npm e from install, I from install, then d-t from developer, right? So we're going to run TypeScript or anything type level is just a developer extension. So we don't need this in production. So we're going to just go like for TypeScript. We are going to install the types for Node, and also we're going to install the types for Express, which is the framework that we're going to be using to create these APIs. It takes some time, not as much as it used to take, but takes a while now. And well, for now, let's just do this. We are going to install the actual extensions like Express and other things later on when we use it. But I wanted to point out that we still need to initialize TypeScript. So when we initialize TypeScript in the internal folder, we need a file called tsconfig.json. So to do this, we can do npx tsc init, and it's going to run and create this magnificent file for us. Let me take this out so you can take a look. It's a simple configuration file for TypeScript. It comes with all these comments because it is all the options that it's possible, and you can just like remove them if you like. I'm just gonna leave it here, and the source code for this repository is also with these comments, so you can take a look. But we're gonna change just like very little things on this. We are not gonna change a lot of stuff. We're gonna keep the same basic stuff. It comes from like reasonable defaults for that. We're just going to tell it to change the root directory. So this guy here is going to tell us where our source files are located. So we are on source. And we want to make it output to another place called dist, right? Remember that we did everything over there. So we're going to look for out there. And this is going to be dist. We're basically telling TypeScript that we are going to read from a source folder and output that to the dist folder. So whatever structure that you do in the source will be repeated in the dist folder as well. So if I put like other folders in the beginning or other files, they're going to just copy everything over there. And basically, this is the only thing that we're going to change over there, because we can also change how strict TypeScript is with you. So TypeScript was meant to be easy to migrate from like JavaScript to TypeScript. So you can have your existing JavaScript application, you can go up and up for TypeScript. So it supports JavaScript typings, and you can say, hey, I don't want you to check this, I don't want to check that. But by default, it comes with this option here, strict. So strict is the most strict option ever. So you can actually enable all the types. So strict no checks, bind, call, apply, everything. It's going to check to make sure that your project is really typed. So if you're creating a new project, this is the best option. If you already have a project with JavaScript, this might not be very good, because this is going to give you like a ton of errors, because it's very strict. You can remove them, these checks manually later on with these options. Right, so we've created our services. And now what we're going to do is like the structure of our API will follow the thing. Like we're going to have a app config file, so a configuration file with our environment variables. So we're going to get like the API keys from Traffic Lab and stuff. We're going to have the port, the API URL that they're going to give us. And everything is going to be an environment variable. So we're going to run this inside our environment, and we're going to load this on startup, right? So to do this, we're going to create a file here on the root called .envrc, right? Envrc is a file from a little guy called direnv. So direnv is a Linux program that runs in .envrc files and loads these environment variables inside your environment. So we're going to export like some variables here, like port. So this is going to be 3000, export API key, which is going to be something that I'm going to put here soon, and export the API URL. And I already have this API URL here because I don't want to check it up. But this is on the Traffic Lab website. If you go here, and for some reason I cannot see it, let me toggle the full screen. So we're going to use the SL APIs, and we're going to use the real-time departures, right? So this is basically the API key that we're gonna, the API URL that we're gonna use. So API, SL, C, blah, 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 blah. We don't need this part here now, because we're gonna compose this later on. So our API URL is gonna be this one, right? So we're gonna get a JSON file. Cool. So first thing, we're gonna tell direnv that this is a bash script. And now if we go, I already have direnv there, you can just go there, but I can do direnv allow, and you can see that it's exporting this here. So if I do like echo API URL, it's going to give me the API URL, right? So it's loaded in our environment variable. So now we need to load this inside TypeScript. And I have architecture that I like to follow, which is an app config. Then we're going to type this environment variable so you know what is coming from the inside. And we don't have like this, changes that we need to do, or we don't know which variables are coming. We always know which ones are coming, and we always know which ones are required or not. And to do that, we're going to use a library called Zod. So I don't know if you know Zod. Zod is an amazing library from this little guy here called calling. That do TypeScript validation. So you pass on an object to it, and you say, hey, I want this thing to follow this structure. And it's going to say, OK, now I'm going to enforce this to you, and I'm going to give you back the types for that. So it's meant to be used with TypeScript. So I'm going to create another file here, config.ts. And inside this, I'm going to start our validation. So for that, we need to install Zod, right? So npm install, this time not a development extension, Zod. And now you're going to see that in our package.json, we have Zod. And Zod exposes some things. One of them is an error class that we're going to use, and Z. Z is what we want to do it. So from Zod, right? So now we're going to type in these things. So basically, we're going to have a schema. So I'm going to say config schema. And this schema is going to be a Zod object, which is from the following shape. We have a port, right? This port is a Zod number, and default is 3000, right? So this is what we put over there. So if it doesn't find a port, it's going to just put 3000. It's going to make sure that this port is a number, not any other thing. Other than that, we're going to have the API URL. API URL. It's going to be a string and needs to be a URL. This is required, right? So, and the other thing is an API key. This is also a string. And we're going to, by default, Zod makes everything required. So if one of our keys in this object doesn't follow one, it's going to error out, and we're going to catch this error. So we're just going to export a function that's going to load our config. So we're going to do export. In TypeScript, we can export directly, because this is like, this is not even TypeScript stuff. This is ECMAScript modules. So it kind of uses by default. Now it's a default thing in JavaScript as well. You can use it without TypeScript. But I'm going to export a constant called load config. And this is going to be a function that's going to do our parsing from the schema and also the error parsing. So we're going to do a try catch here. And this error will be a Zod error. So what we're going to do is like we're going to create an if, see if error is an instance of Zod error. So if this is an instance, you can see that it already imported here on top. We're just going to do console.error. We're just going to do like invalid config, and then we have this error issue. I'm just going to put the error fully. I don't need everything. And I'm going to force the process to exit with a status code 1, which means that we had an error, right? So, by the way, I forgot to ask you guys here and you guys and the string. Who here has worked with TypeScript before? Please see some hands. Nice. That's what I was expecting. No one. Very good, very good. So I'm not just talking to people that know TypeScript. And are here just to make sure that I am talking about TypeScript. So nice. So what we're going to do is that we're going to see that config is from that type that we want. I want the config object to be exactly like this guy. So what we're going to do is like const config will be config schema.parse. So I'm going to parse the process.env variable from Node, who here already works with JavaScript. So I want a little bit more people. Nice, nice. So process.env in Node is all the environment variables that come to our application. This is an object which will be most likely with all these 3 keys. We can do some more advanced stuff. Like as you can see, like this is uppercased. And if I wanted to have like camel cased, we can change the type. So TypeScript, the whole language, the superset, is actually a Turing complete language. So which means we can do type level stuff with any complexity. So we can do like test runners. There is a guy that programmed Mahjong, the game, completely in TypeScript. So it's kind of nice to see it. So we can do things like this. Let me show you very, very quickly so we can have time to do it. Let me see. Blog. This guy. So in this repository, this is a full TypeScript project for Deno. We have the same idea, config.ts. And as you can see, we have this little guy here. So this is going to extract. You can do like some sorts of functions. We can do a lot of things. So what we're going to do is basically we're receiving an uppercase key, like port in uppercase. And I want this to be like this, right? Or this in camel case. So I'm just going to say, hey, if you get this port in uppercase, you're going to just see, hey, I'm going to put this type here in an object, which is camel cased. And then it's going to type for us when we use the object everything in camel case instead of uppercase if you want. Okay, so in this, I'm not going to talk about this like generics. This is a lot of things that it's very advanced in TypeScript, but you can do basically everything. This is called type level programming, right? It's a paradigm of like functional programming that you can use with TypeScript as well. So it's pretty nice if you want to dive in deep into it. It's pretty cool. So first, coming back to the code, we are parsing the schema here. And then we're just going to return a new object for us. We're going to reject like, objects with config.port. And the cool thing is like, if you parse this in vanilla JavaScript, like no JavaScript, you can receive undefined if this is not there. But since we are parsing the schema, we are making sure that all the environment processing and environment variables are there and they have the correct type, right? So if it's not a correct type, Zod's gonna error out and scream at us. So we don't need to worry about if this is correct or not. So API URL, API key. The other way we can do is doing this, because now TypeScript knows that we have a function that returns this object. And this object could be extended to an interface, for instance. And to do that explanation that I told you about, we can use like types and interfaces kind of interchangeably. So let's say we have an interface called base config, and this base config has a port, which is a number. And I want to extend this interface with API config. So, right? So extends base config, and we have URL, which is a string. In the end, our API config will be the port and the URL, an object with both of them, right? So we're just gonna we're saying to TypeScript, hey, I want this base config, but can you add this URL to this as well? And in the memory of the computer, this is gonna be a single block, right? So a single structure called API config. We can do the same thing in types. So we can do types or type base config. It's equal to this guy, and type API config is equal to this guy, and we can do type final config. It's equal to an intersection between both systems, both types. I'm not going to explain a lot of this, but this is set theory. So basically you have a set, which is the first config, which has port, and the second set, which is API config, which has URL. And if you intersect that set, like if you put like those two together, what is the set that has both of them? An object with both keys, right? So if you do final config, we are not going to see this here, but we can do final config dot, please complete. Let me just put it in a const A of type final config, and then we can do, come on TypeScript, where, oh, because of this guy. So we have port and URL. It's the same idea. If you do an interface, this is the same thing. The
You actually
problem
got
is,
a question on that.
Go
I have
on.
never heard anyone claim that interfaces are more performant than types. Could you explain?
Interfaces and types are very difficult to talk apart because the performance is negligible, I guess, if you're doing small objects. If you have like a really large object, if you put like an interface and extend it with other interfaces, you're actually creating a bigger struct in the memory. So you have one object with several keys. If you do this for types, like I did here, this one, you actually have all the possible intersection of these types in the memory as well. Because this is an easy application. If we have types with more than one possibility, let's say we have a URL here, which is a string, but we also have a key that is a string, but the base config has a key that is a number. So the final object here will be them const A final config equals this guy, and you're going to see that this this one doesn't. Oh, there's a key here, and this key can be either of type string or number, which means they don't intersect. So this is never. So we will have like intersection of a type with the three objects, with the string, the number, and the never. So this takes more memory. In general, being honest, the the performance gain that you gain from taking interfaces or types are so little that it doesn't change a lot for most people, like only edge cases.
Thank you for being honest.
Yeah, it doesn't
So
change a lot.
Adam Code asks, should a project pick between using interfaces or types?
Sorry?
Should a project pick between using
No,
interfaces and types?
no, you should use both, because types allows you to do things that like extract and stuff, processing on it. Interfaces are always static, so you cannot do processing. Like you cannot pick one object from an interface or anything and create another interface from it. Interfaces need to be static. They need to be all the time what you need to do. Objects can be mutable with generics, right? So interfaces cannot have generics and stuff like that. So it's a bit more. If I put say like interfaces are more fixed on it. You had a question over there. Yes, it's compile performance. So if you have like a big project, it's gonna take more time to compile or less time to compile. Yes, but that's a way like this is how TypeScript actually works behind the scenes, because like it works a lot with set theory and stuff like that. So they're never gonna fix it because it's part of how the language works. So it can work together to make it. If they fix this, most likely you're gonna lose other features from this. So it's pretty nice to see that there are always takeoffs. But it doesn't mean that you need to choose between one or the other. You need always to see like, oh, if my object is static, like an API response, then it's an interface. If my object can be like, oh, it's a promise of a single type, like say a promise of a string, but this promise can always be used on other things, like it's a promise of an object, a promise of a number. It's the same object, but the type that it's going to return is different. Then you can use a type, because you can pass on like generics, like this guy here. You see? Promise of app config, which means that this promise returns an app config object when you do then and catch. So when you resolve this promise, it's going to return an app config. So if I want to return a string, if promise was a string, then it's going to return a string. This is what objects allow you to do. If this was an interface, you couldn't do this. You need to create one interface for each type that it returns, because it doesn't accept generics. That's the main difference between one and the other. You can think of like, I know, maybe structs in C++, stuff like that. So it's kind of the same idea. But I also not a C++ programmer, so I don't know a lot about it. Let's continue.
Have any C++ programmers here? No. Oh, yes. There's always one. That's good.
Yeah, thank God there is always one, because if they weren't there, then we're really terribly lost.
Keeping us honest.
So okay, I'm gonna well, we can do this like with index or anything else, but I like to call this the main app thing, and then we can do like node app and app, just to say that this is the main file. So now we're gonna do the API itself, right? So we're gonna do here install Express, which is the most famous web framework for Node. There are others. I encourage you to use others. Express is like 10 years old. It's people like to. It's good. It's not bad, but it comes with a lot of dependencies and stuff. It's big. It's bloated. So there are better alternatives if you want to use like Koa, which is from the same team but smaller, right? But for this, we're going to use Express because it's the base idea for everything. So we're going to import Express from Express. And also we're going to import like Zod and stuff, but let's just create our app. So const app equals Express. So this is our API. Const config is going to be our load config. You can actually do this before, because if it fails, it doesn't even instantiate Express before that. So it's pretty nice. You can even do like this. So it just loads everything first, and if it fails, it doesn't even lose any time doing anything else. So but I like to do this way because it makes more organized. Nice. So we have the Express here, and then we are going to create our API. So I have my little sheet here so I don't get lost. Our API is going to be a simple GET request, HTTP GET. So we're going to do an app.get, and it's going to be a /times for the timestamps, and we need to bring on the station ID as per this guy. So we need the site ID here. This is what we need to get. What is the site ID? No idea. We need to use the other API to get the site ID, but it's a number. This I can tell you. And I have one that I know for sure here because I searched before, but I really recommend that if you're going to test it out in your home, you use this stop lookup here. So you pass on a string, it's going to give you site ID. Good. Then this takes a async request and response. Let me look at the time. Res. And you're going to see that when we create this, TypeScript automatically types this as a request. And TypeScript automatically types this as a response. And these are types. As you can see, these are response of these 3 parameters. This is, I think, type parameters, body parameters, and query parameters on the string. So you can change them. And you can actually type them manually if you want. But I'm not going to do this because it's going to be more confusing. Then we're going to need to check if our station ID is a string, which is always a string because otherwise it's never going to get into this guy here. But we need to transform that string into a number, right? And I actually don't need to do this manually, but I'm going to do this so I can show you more functionalities from like Zod. So first thing, schema, and then we do a z.object. So we're going to send in the station, right? The station ID that we want. So station ID is going to be a string when it comes here. I need to import Zod in the beginning. So import z from Zod. Nice. It's going to be a string, but we need to transform this into a number of sorts. So how we're going to tell, we need to do like number all the time. We can tell Zod to transform it for us. So we can do like transform. It's going to receive a function. This function gets the value that's being received and outputs what we want this value to be. So we want this value to be a number. So it's going to be number of a value. So when we parse this, no matter what you send to our thing over there, it's going to do just string. And if it's a string, it's going to try to transform this into a number. And if this number is valid, we can go on. So basically, if it's not a number, like if it's not a number, we just do if it's none, schema. Oh, shit. Here. Let me just parse the schema first, right? That makes more sense. So const station ID equals schema.parse rec.params, right? So we're going to take the params, which is this station ID, and we're going to parse it. So if station ID not a number, station ID, which means if this thing is a number, then we can, if this thing is not a number, none, we cannot do anything with it. So we just return, nothing to lose over there. So we're just going to do res dot status, and it's going to be a 400 and invalid station ID. That's it. We can do a 422 as well, which is unprocessable entity, and do return. So we don't want to go any further. So if you send like /times/banana, this is not going to respond to a number, which means that we cannot do anything. So now we're going to do an API call. We're going to call the SL API, and we're going to see if this is the correct response. So API call, we're going to use the native fetch from Node. This is only available in Node, I think, 18 plus. We are using version 18 here. So we're going to do await, fetch, and then we're going to do config API rel slash, not slash, it's key, and then config dot API key, and then also what we need to do, site ID equals station ID. And the last thing, we're going to use time window. I think it's 60, which is the time that we want to use this. API URL. Oh no, that's no problem. Yeah, there's a process exit here, so it's gonna do. It's because config can be undefined as well. So what we are going to do, because since this can error out, this can be undefined, but we are never catching the error because we're never getting into the thing because it's gonna error out first. So what we're gonna say is we're gonna say to TypeScript here. As you can see, there's like it's either this or undefined. So we're gonna say, hey TypeScript, I know that this is always gonna be something. We just put exclamation mark, and then undefined goes away, right? We're gonna say, hey, I am pretty sure this is correct. So this is something that we don't usually do. Like it's better to just treat your errors right. But sometimes in this case, we don't have like a way to do it and tell TypeScript that this is going to be always correct because it throws an error. So if it throws an error, it doesn't know how to exit or something. So we basically need to tell him that.
Question on the errors.
Yeah.
Does TypeScript have an on error resume next feature?
No, but JavaScript has. You can just catch the error and continue. If I remember correctly, I used this on Visual Basic like 2000. I don't know, a long time ago.
Any Visual Basic programmers here?
That will
see,
be
there's always one.
that will be like very hard to find.
Update on the C++. There's quite a few C++ developers on the chat as well, so not alone. This is good diversity.
So basically, what we're going to do is now call the API. The fetch is just the network processing that we're going to do, and now we're actually going to call the API and transform that thing into a JSON file. No, actually, a JSON object. We're parsing this. So API call dot JSON. But as you can see, this is typed with the worst type ever, which is any, which means there is no type at all. This is just JavaScript, basically. So this is never good. This is a thing that we need to change. So we're going to type in the returns from the API. So the API, this, what is stop lookup? This little guy here. Yeah, departures. Yeah, it returns this much stuff here, a lot of them. So I'm just going to spare you from this is the terrible part of APIs that are not typed because you need to type them manually. So you need to add all the types in yourself. So what I'm going to do, I'm just going to copy paste and I'm going to explain to you why am I doing this with the interface. So let's go first with this guy here. And we're going to put it here. So lots of things going on. So the main interface that we're going to use is this transport info. So transport info has all these options with our strings, numbers, arrays, and stuff like that. And we have like one option called deviations. Deviation is an array of a deviation that I called, because this type is also used here. So we can reuse those types. So this is a very common technique. So we create like smaller interfaces and we compose those types together so we can create a bigger one. In this case, we're just going to reuse one of those because we have also station info here. That's the final interface that we are going to use. So we have this station info. This is the type that we're expecting. So this guy will be typed station info. And this station info is a set of, it's an object with a set of options. These options, like one of those is arrays of transport info. So the SL API returns for us an array for each type of transport that we have here in Stockholm. We have metros, buses, trains, trams, and ships. And each one of those is a different thing. So I don't just like type in the same thing over and over again. I just abstracted this into an interface and I put it here, right? So basically what I'm telling is, oh, every time you get this, it's going to be an array of this. So basically an array of objects, like a list of these objects here. And inside this, we have a deviation, which is the same thing. Every part of the API returns a deviation. And a deviation is basically on every response, so we don't need to type in. This one, as you can see, it's a type, right? I just put it here because I wanted to show you can do both. But correctly, this would be an interface, right? And I'm wrong here because I don't have an equal. So this correctly would be an interface. But you can use types as well. No need to be like this. Nice. So I think this is actually wrong on one level because of this here, but let's move it on. Otherwise, we're never gonna finish. So, well, this is our response. This is one of the reasons why you should use TypeScript, because it's way easier to type in and to tell what's coming from the external sources. So this is the most important part. Now, the final thing that we need to do is just to catch our error, right? So we have this, and now we're going to just return, actually res.json. We're going to pass on the station ID that we received, so we can know this, and results is going to be data dot, and we have response.data here. So this is another cool thing that we do. And we need to type in our error, right? So I'm just going to wrap everything with try-catch. This is an extension, by the way. So we're wrapping everything. So if error is an instance of Zod error, then we're just going to do res status invalid station ID. And I'm just ending it up here because I don't need to put anything else. And in the end, I'm just going to say, hey, app, listen to this port here. As you can see, it only get me from the port. You see that there is like this, but it already showed me the port because the port is the only number that we have. So then, after it's listening, I'm just going to do console.log, and port is listening on this one. Okay, so I'm going to get my API keys. I don't have any problem letting you know about it. It's free. You can all use it. I'm just asking you not to do this a lot because I have 15 requests of an API key, so per minute. So it's very, very rate limited. But we can do this, like a nice thing to do. So after we do this, we do an npm start, and hopefully this is going to work. Oh, obviously. Oh, dear env.
The moment of truth already. Oh, ready to go.
All right, so this is the thing. Expected a number, received a string. Why? Because we are parsing probably our variables wrong. Here. And why this is so small. Obviously it didn't work, right? Because we are in our, okay, path port, expected a number, received a string. Oh, sorry about this. Everything that we're going to receive here is a string because it's a process.m, right? So we need to parse this as a number here. So we need to put number here in the port. Now, if the gods of demos allow me, it is listening on port 3000. So, woo! Yeah, sure up for this. Now we're going to use Thunder Client to request our API. So locally, I'm listening to port 3000 times, and the station ID. The station ID that I used was 9117. Don't ask me how I get this, but
You know
just,
all the numbers by heart.
yeah,
We know that.
trust me, it is something. And then we can just wait. And then we can see that it returns. Let me get this guy here. And it returns the station 9127 and the metros and everything else. And the cool thing about this guy is that you can also get from the response, there is a way here to get the types from it. I just need to
Just
make
a quick Swedish lesson for everyone not here in Stockholm. Display time new is display time now. So the train is actually right below us here in the reactor. So if we were there, we would actually see the train coming.
Yes, and
without the API.
the tunnelbana is the metro, green line, right? This is all my Swedish guys. I don't know
Woo!
anything else, but yeah. Um, right, so you can see that all the times are coming here. I think that's because of the size of the screen. We don't have the ability. Let me see if it's in the below here. No, we don't have the ability to get the types from this. Think we can do. Oh, here, like nice snippet. So this extension allows you to generate types from the results. So this is actually how I got the type so fast on the other one. But as you can see, it gets a lot of things together. So we need to, do it generates like a bus for one, and then there's a lot of things, consequences, and blah 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 blah. So we're not interested in this in the beginning. But well, this was how you create your first TypeScript API. It's a pretty simple API for now. We're going to extend this more. And for a challenge for you that are here and you that are on the streams, for next week, we're going to use the other API too, the station lookup, because we need to know the numbers. We're just going to. So try to implement this other endpoint of the API. So like putting the API keys and stuff and returning the number of the site ID for that. And then we can do this on Korey. Actually, we do this on the React frontend to call our first API to get the station ID, then call it again to get the station timetable, right? So I guess I end here my presentation, and I want to ask me a lot of questions now, please. Nice question. Using what? I don't. Zod. Yes, it's pretty nice. We can use this, but yeah, yeah. What we usually do is like Zod is a validation library. So usually what we need to do is like for data we don't know the type. So like user input data mostly. So if we had a payload here, this is what I did here. This is completely unnecessary because everything is going to be a string, and we're going to call an API. So we can call it with a string or a number, so it doesn't matter. But I wanted to show this thing. But usually what we do is like if you send in a payload, we match that payload against the Zod schema, and then we parse them together. And then we are sure that the user sent the right data. They're not using like SQL injection, stuff like that. And it's perfect. Before Zod, we used to do it with Joy, which is another schema loader or schema validation from Happy, which was made on Walmart a long time ago. And even before that, we used the original specification from JSON Schema, which is pretty nice actually, but you need to write so much to just do like a small API. But it's pretty good. It's not that bad. And if you really want to see the APIs, I think I'm just gonna try to find this here, but I think I've done a typing of a JSON API somehow in validation. This was a really long time ago. This was for a project that we did. And types, it should have interface here. So if you want to study a bit TypeScript, this is JSON schema types. This was a mess to do because it's very complex and it's recursive. So if you really want to like get into TypeScript and see how it works, try to type in. The best way to learn is to get like something very difficult in JavaScript, like JSON schema or something that's recursive, something like this, and try to type in how we would like to be the types that you want to return from this. It's not perfect, like this was done like 3 years ago or 4 years ago, but as you can see, we have like a lot of generics, a lot of stuff. Another thing, you can always look me up also on the GitHub. There's a lot of TypeScript projects there if you want to see how things, how I work with TypeScript in general. It's not
Have you used Yup?
what?
Yup.
Yep.
Yup.
What is?
It's a schema builder.
For React, right?
Yeah, yeah. Not just for React, but it's heavily inspired by Joy. This is what the npm page says.
Yeah, I
Yep.
know about it, but never used it.
Yeah, someone mentioned that in the chat.
There's I personally don't like joy. I'm not a joyful person, but
Yep.
but the like joy is nice if you want to, like, it's simple, it's easy to read. Zod got a lot from joy, but Zod is more type safe, I guess, because Zod gives you something really nice that is this little guy. So you can do like const config type, and you can see z.infer, and you pass on a type of config schema. And why doesn't this exist on Zod? Right, unless they change this somehow. Let's see on the documentation, because I use this a lot. Here, infer, infer, type inference. Yeah, z.infer. I don't know why it's not working, but what this does is that, oh, because it's, yes. So infer is a type. And what you can say to it is like, I want to infer the type of this thing. And this is going, I didn't create any types for the schema, but it's going to parse the schema and it's going to give me exactly what it looks like. So in Joy, you need to do both. You need to create the schema and you also need to create the types because it's not type safe. There is another thing called IOTS that does almost like this, but it's terrible to use. And we have this in Zod Infer because it's amazing. This is why I am a Zod fanboy for a long, long time. But also, what I wanted to show you before is another thing.
We've got another question as
Go
well.
on, go on.
It's the classic question. Maybe you're also asking this in your head in the audience. Anytime you show TypeScript, someone always asks this question. So I'm going to put it to you to see what your answer is. It's, oh, it feels like you spent a lot of time writing TypeScript, as much as you would do in JavaScript, but your only error was with TypeScript. So is it proven that TypeScript actually saves time?
What, in my only error?
Yeah, your only error, I guess, is with the TypeScript error that you had. Remember the number?
Oh, yeah.
So he's asking, like, is it really saving that much time because you've written almost just the amount of the same code, but
Yes, it does. I wouldn't say it saves time because, like, when you're coding, you're actually coding more than you're coding in TypeScript in JavaScript. This is true. Like, you're writing more. But if you have like a big project, like we have in Klarna, for instance, some projects that are like thousands of years old, that connects with, I don't know, 50 teams in 300 APIs, eventually you're going to lose track of what you're typing in. So like you're calling an API from something that was made 500 years ago by someone that might or might not be even alive. So something that happens like, what does this thing return? So what does this thing takes as an argument? And as we all know as a developer, documentation is not the strong point of our community. So what we do is like we embed the types, the documentation into the types. So we need to change the types, so we need to change the code, and documentation and types are almost like the same. And we can do both. So you can know the gains that TypeScript give you is in the long term for bigger projects is that you will always know the maintainability. You always know what is coming, what is going. You can import types from npm packages like we did with types, express types, anything. So what we used to have, like this is a real story. We used to have I worked in a company that we used to have like several systems, and all the systems had like a shared type repository. So everyone would use that same repository, and then if anyone changed the repository or the types, this would be reflected in the repository, and then we could just get this in. Today, this is way better done with something called TRPC, which is from the same guy that created Zod. But the idea is that, I don't need actually to explain a lot, but the idea is that if you change the return type from your API, like someone somewhere in the world has this API and it changes from like a message to something else, you already know that this is wrong and you can update it. So it's very, very easy to maintain a TypeScript project in the long run because it scales. So TypeScript was originally sold by Microsoft, the creator, as JavaScript that scales because it's extremely hard to scale JavaScript without losing information on what you're actually doing. And we have this. Every company has this. I'm gonna tell my story, but like we have APIs at Klarna that were made thousands of years ago, and we don't know what comes from them or to them. So we need to go to the teams that created them and ask them about it. This take time. This take resources. This take like people to do, and like something that could have shipped in 1 week takes a month because they might also not know because they were not there when it was created. So they're going to go to someone else, that goes to someone else, that goes to someone else. It would be even easier if you just had the type in, right? Just like here. So that's what we learned from other languages like Java, C Sharp, C++, any type language in general. So
Cool. Yeah, everyone in the chat is, what, a 5-year-old API? Because I think you said it was something really old. So that's the quality comments that we're getting in the chat.
the 5-year-old API.
No, the 500-year-old API. Yeah.
The ones that use SOAP as web
Yeah,
services.
it was also
That
mentioned
is
that was the soap. Yeah. Cool. Well, we're gonna cut off the stream now, but we'll all be available here for further chat. And yeah, everyone, please join next session on the 15th. We won't be here; we'll be streaming only, but it'll be building the front end and hopefully the other API as well, so we can actually do the location lookup.
Definitely. So can I say one last thing?
Yeah, yeah.
Another project, if you want to look and take and see how it's how I made this, how I work with this, is this project. This is like my pet project from like more than 5 years ago. It's a GraphQL parser. It parses GraphQL syntax into JSON, and there is a parser. So I need to parse in the queries, the GraphQL queries into a JSON file. So basically, this is what I did, and it receives like GraphQL things and parses into something that looks like this guy over here. What is the typings here? So it gets something like this. So you can see it's like pretty complex. It is recursive as well. Recursive things are very difficult to do. So go there. It's called GotQL. It's not very useful today, but if you want to take a look and use it, it's pretty nice. It was a very fun project to do. So yeah, 2017. Thank you.